Today we're going to look at radical equations and problem solving. So this is solving for x buried in radicals. One thing that you really want to make sure you're careful about here when you're solving these problems is checking your solution. That's going to be a huge step here. So let's just go through the process. We want to solve for x. X is buried underneath a radical. So we have to offset everything. Just like if we were solving a one-step equation, how would you offset the multiplication of 2? You would divide by 2. So same exact process. We're trying to offset everything that's happening. So I want to get rid of this radical of 3x minus 2. I want to get rid of the radical because I want to try to get this x by itself. So how do I get rid of a square root? Well, if I have the square root of x, the square root of x squared will just be x. If I square a square root, I unlock everything inside of it, and now that radical is gone because what's happening is the square root of x times the square root of x is just x. If you've been watching the last couple of videos, this has been a common theme about multiplying a radical times itself, and you get that term back from the inside. I'm going to erase this. Actually this square root of x squared equals x. So let's go ahead and solve this. So I'm going to square, and whatever I do to one side, I do to the other, just like a solving equation. So square root of 3x minus 2 squared is just 3x minus 2. I'm not even going to write anything out for that because, as we just talked about right here, 5 squared is 5 times 5, which is 25. Now look, it is a multi-step equation. So I'm going to add 2 to both sides. I get 3x equals 25 plus 2 is 27. And then we divide by 3. So we're going to get x equal to 9. You do want to just get in the habit. I'm just checking it. I might do some mental checks more than anything rather than taking the time out. But if you go through this just mentally, 9 times 3 is 27. 27 minus 2 is 25. Square root of 25 is 5, so checks out. The key, though, is this radical was by itself on one side of the equal sign. If it's not by itself, like for example on the next one, if I square this, I am now going to have a binomial squared. That's going to move the radical around. It's going to put it in multiple spots. So that might not work out. So let's get the radical by itself. So I'll have square root of 6x minus 5 equals, and I move that 5 over because now I have the radical by itself. Now it's exactly like the last question that we just did. So I'm going to square both sides because that radical is by itself. And that's going to give us square root of 6 minus 5 squared is 6x minus 5 equals 5 squared is 25. I'm going to add 5 to both sides, and this just kind of shakes out the exact same way as the last one. Divide by 6, x equals 5. So let's do a quick check. 5 times 6 is 30. 30 minus 5 is 25. Square root of 25 is 5. 5 minus 5 is 0. Checks out. Cool. Next, number 3, the cube root now of 6x equal to negative 3. So the cube root's by itself. Same thought process, though. I want to get rid of the radical. So as I was saying with like the square root of x squared is x, how do I get rid of the cube root? I would raise it to the third power because that's going to be x because I get x to the 3 over 3, which is x to the first. So same thought process. If it's the fourth root, raise it to the fourth. Fifth root, raise it to the fifth, and so on. So I'm going to raise this to the third. Cube root of 6x raised to the third is 6x equals negative 3 to the third is going to be negative 27. Divide by 6. X equals 27 over 6. So 3 goes into 27, 3 goes into 6, so that's going to be negative 9 over 2. Do a quick check. Yep, so 6 times negative 9 over 2 is 27, or negative 27, cube root of negative 27 is negative 3, checks out. So those were just setting the foundation of how do I get an x by itself when I have that radical. Like, what is the concept here? What is the strategy? The strategy is get that radical by itself and then square. Now, in some instances, more work will be created, though, from there. Like on this next one, number 4, I have the square root of 32 minus 4x equal to x minus 5. If I square both sides, look at what's happening. This radical is gone, so I'm going to be left with 32 minus 4x. But look at the right side. Now I have x minus 5 being squared. So that's going to be x minus 5 times x minus 5. That is a binomial being squared. So I have to do x times x times negative 5 times x, negative 5 times negative 5. So x times x is x squared, x times negative 5 is negative 5x, negative 5 times x is negative 5x, plus 25. So x squared minus 10x plus 25. So I just combine like terms here. Anyway, I did that a little bit quick, but I really don't want to have this video extend long because we're multiplying two binomials together. So x squared minus 10x plus 25. Now let's set up a quadratic here, get everything over to one side, set it equal to 0, and see what's going to happen here. So I'm going to subtract 32 from both sides. I'm going to add 4x to both sides. So let's see, 0 equals x squared. Then I have negative 10 plus 4, which is going to be negative 6x. 25 minus 32 is going to be negative 7. Look to factor. So this is going to factor to x minus 7, two numbers that multiply to a negative 7, add to negative 6, x minus 7, x plus 1, equal to 0, right? Negative 7 times 1 is negative 7, negative 7 plus 1 is negative 6, checks out. Set both factors equal to 0, so x minus 7 equal to 0, x plus 1 equal to 0, so x equals positive 7, because we got to add 7 to both sides. Subtract 1, x equals negative 1. We get two potential solutions, and this is where the check is going to really come into play. I'm not saying that both of these are going to work, or one of them's not going to work, who knows, but definitely check to see. So I'm going to just do this in my calculator here. 32 minus 4 times 7, so I'm checking 7. That's the square root of 4, which is 2, equals 7 minus 5 is 2. So the first one checks out. Let's check negative 1. 32 minus 4 times negative 1, square root of 36. So I got 36 there. 6. So I get 6 equals negative 1 minus 5 is negative 6. Doesn't work. So only solution that works is x equal to positive 7. Check your solutions. All right, next one. So number 5, x minus the square root of 12 minus 11x equal to negative 24. So on this one, we have this like x over here. We don't have the radical by itself. So same thing as we just talked about. Let's get the radical by itself. I'm going to be left with negative square root of 12 minus 11x equals negative 24 minus x, or negative x minus 24, doesn't matter. There's an extra step here. I don't think you absolutely have to do this, but I like to just play it safe and just take care of everything. I'm gonna divide by negative 1 on everything just to get that negative 1 coefficient, because if that was like a 2 or something, like, I don't know, I don't like develop any sort of like weird habits where like it works here, it doesn't. I would just get rid of that negative. So I'd be left with a square root of 12 minus 11x equals, and then this would become positive 24, positive x. I'm just going to write this as x plus 24, because negative becomes positive, so it's just going to be positive and positive. Now the setup from here is exactly like that last problem. It's exactly the same process. We have a radical equal to that. So some things are going to happen here. So let's square both sides. I get 12 minus 11x equals, then we're doing x plus 24 times x plus 24. X times x is x squared. 24x plus 24 times 24, no clue, 576. X squared plus 48x plus 576. get everything over together. So I'm going to move everything to the right to keep that x squared positive. I'm going to subtract 12 here. I'm going to add 11x here. So I'm going to get x squared. 48 plus 11 is 59x. 576 minus 12 is 564. Equals 0. So move everything over to one side. Now I have to factor. Oh boy. Two numbers that multiply to 564. And add up to 59. Two numbers that multiply to 564, add up to 59. Let's see. So 564, add up to 59. I would definitely start around like maybe 8. What is that? 564 divided by 8 doesn't work. What about 564? Like, let's jump to 12. 12 and 47. There it is. Okay. So I knew I was like kind of going through my factor like 2, 3, 4. Like, that's still going to be a pretty good distance away. But 12 works. So this is 12 times 47. So that's going to be x plus 12 times x plus 47. Luckily, they're both positive. Like, I wanted to multiply to a positive, add to a positive. So the factoring wasn't as hard as it looks, but you just go through your factors and you can get there pretty quick. So that means x is going to equal negative 12. I'm going to just skip a step there, just set that equal to 0, subtract 12. X is going to equal negative 47, set that equal to 0, subtract 47. So we get these two potential solutions. I would definitely check these, as I've been saying throughout here. So I have these potential solutions here. Let me zoom this out a little bit. I'm going to erase the multiplying there. So let's check negative 12. So negative 12 minus the square root of 12 minus 11 times negative 12 equals negative 24. So let's check. So 12 minus 11 times negative 12, square root of 144. Oh, what happened? So on the inside of that radical, I get 144. Sorry about my screen there. So negative 12 minus the square root of 144 is 12 equals negative 24. Negative 12 minus 12 is negative 24. Checks. All right, cool. So negative 12 worked. Let's check negative 47 now. So this is going to be negative 47. I just write 14. 47 minus square root 12 minus 11 times negative 47 equals negative 24. My gut's telling me this is not going to work. Let's see. 12 minus 11 times negative 47. Square root of that number is 23. So I have negative 47 minus 23 equals negative 24. Negative 47 minus 23, definitely not going to work. It doesn't work. Negative 7 equals negative 24. No. So negative 47 is not a solution. Interesting problem there. Good one. Let's keep moving along. So number 6. This one's a little bit of a tougher one because we have two radicals. So you might think, well, I get the radicals on one side and I'm going to square it. That's a good thought, but if you think about multiplying a binomial together, what ends up happening is now I'm just removing, like if I had square root of 2 plus the square root of 3, let's say, times the square root of 2 plus the square root of 3, what's going to happen is these radicals will be gone, these radicals will be gone, but then you'll end up with square root of 6 plus the square root of 6, right? Because square root of 2 times square root of 3 is square root of 6, 3 times square root of 2, square root of 6. So we still end up with a radical. So that thought is good. It's just not going to work. So let's try something else. What we should do is I would get this radical by itself and then square it. So then that way I at least eliminate a radical somewhere. And then we could start moving things around. So let's just see what happens. So I'm going to get rid of the square root of 3x over here. So I'll have the square root of 3x plus 1 equals 2 minus the square root of 3x. And I know it's not going to get rid of the radical right here when I square both sides, but at least I'm eliminating a radical somewhere. So I'm going to square both sides. So square root of 3x plus 1 squared is 3x plus 1 equals 2 minus square root of 3x times 2 minus square root of 3x. 2 times 2 is 4. 2 times negative root 3x is, 2. 4. And then minus 2 square root of 3x minus 2 square root of 3x plus 3x. Square root of 3x times square root of 3x is just 3x. So then I get 4 minus 4 square root of 3x. Combine like terms. Negative 2 minus 2 is negative 4 plus 3x. All right, so let's write that down. 4 minus 4 square root of 3x plus 3x. Now if you look at our thought process, I only have a single radical. I just have a radical right here. So we could still take that same logic of let's get everything over, let's get the radical by itself, we square it, and then see what happens from there. But we're condensing it down to just one radical. So that's, we're getting there. We're getting close. So let's subtract 4 and subtract 3x, which is nice. That's actually really nice that that happens because look, 3x minus 3x, 0. 1 minus 4, negative 3, equals negative 4 square root of 3x. See that? 3x minus 3x is 0, so I've gotten rid of the 3x's, which is actually, I had a little bit of a fear that we're going to create like a quadratic where we'd have to factor, but that actually works out nicely where that doesn't happen. So now let's divide by negative 4. So I'd have positive 3 over 4 equals square root of 3x good step there. Negative over negative is a positive 3/4. Then I just square both sides. Boom, bam, and we get 3x equals 3 over 4 squared is 9 over 16. Could have also, like now that I'm thinking about it, you probably could have just squared this side right here. That actually maybe would have made it a little bit easier rather than dealing with fractions, but it's not like we can't deal with fractions. But now that I'm thinking about it, maybe should have just squared that side. So we have x equals 9 over 16 divided by 3 over 1 is times 1 over 3. So that's going to be 3 over 16. Yeah, because if you just did this step right here, negative 3 squared is 9 equals negative 4 squared 3x times negative 4 squared 3x times negative 4 squared x is 16 times 3x. So then that'd be 3 times 16, which would just be 48, right? 16 times 3 is 48. So then you'd be dividing by 48 on both sides, which would simplify down to 3 goes into 9 3 times, 3 goes into 48 16 times. So you get the same thing. All right, cool. There we go. Next, we're going to talk about the Pythagorean Theorem and how this applies with radicals. So that Pythagorean Theorem is used for right triangles So a right triangle is a triangle that has two sides that meet at a right angle. The components that make up a right triangle are two legs, those are the two sides that meet at the right angle, and a hypotenuse. The hypotenuse is the longest side. The Pythagorean theorem then is leg squared plus leg squared equals the hypotenuse squared. And you might have also heard of it as like a squared plus b squared equals c squared. I just don't like that because you're getting tied into letters, and sometimes like the variable might be like a different letter or an a, and then you're not sure what part that is. Like I just try to avoid variables and just say leg squared plus leg squared equals hypotenuse squared. So number 7, find the length of the unknown side on the right triangle. So what do we have? We have two legs and a missing hypotenuse. So the formula is, this is the leg, this is the leg, this is the missing hypotenuse. So the formula is leg squared plus leg squared equals hypotenuse squared. So 15 squared is 225 plus 5 squared is 25 equals x squared. 225 plus 25 is 250 equals x squared. Now we have to take the square root because I have x squared. So I'm taking the square root of both sides, and I get x is equal to, I'll talk about the answer here, but I'm gonna write down plus and minus. Square root of 250, we do have to simplify square root of 250. 250 divided by 25 is 10. So 25 times 10, square root of 25 is 5. X equals plus minus 5 square root of 10. Just simplifying radicals from before. And the reason I have plus minus, when you are taking a square root, it could be both plus and minus. But since we are talking about the Pythagorean Theorem, since we're talking about triangles, we only want to account for the positive answer because we cannot have a negative distance, and we're talking about like geometry here, some distance. So we only want the positive answer, so we're not going to count the negative answer for that one. So look at number 8. So I have a leg, a known leg, I have a missing leg, and then we have a known hypotenuse this time. So the Pythagorean Theorem is leg squared, so 2 squared, plus the unknown leg, I'm going to call that x, the unknown leg of x, equals the hypotenuse squared, so 7 squared. So 2 squared is 4, plus x squared equals 7 squared is 49. Subtract 4. X squared equals 49 minus 4 is 45. Solve for x, take the square root. And again, when you take the square root, plus minus, but we don't have to count the minus because we're talking about triangles and everything. So the square root of 45, let's break that down. That is 9 times 5. Square root of 9 is 3, so we get 3 square root of 5. So x equals 3 square root of 5. Last one for this set here, and then I have an application to this. This is a known leg, this is a missing leg, and this is a known hypotenuse. Let's go ahead and solve. So leg squared plus the missing leg squared equals a hypotenuse 19 square root 5 squared. Five squared is 25 plus x squared. Be careful here. 19 root 5 times 19 root 5. We're squaring that. So that's 19 times 19, which is 361. Then we also want to multiply that by 5, which is 1805. Subtract 25. So we get x squared equals 1805 minus 25 is 1780. Take the square root of both sides. So we get x equals the square root of 1780. Let's see if I can do anything with that. I'm just going to start chopping this down. This is kind of a big number. I'm going to go up here. So the square root of 1780 is 4 times 4, 45. Square root of 4 is 2. So 2 root 445. Let me see if something else can happen there. 445 divided by 5 is 89. So I don't think so. 445 divided by, yeah, nothing else. So that's going to be x equals 2 square root of 445. Kind of a tough simplification there. Yeah, tough one there. Last question. A application to this. We have Batman is connecting a cable to the top of a pole that is 12 feet tall. The cable will be anchored to a stake 5 feet from the base of the pole. How long is the cable? So this is just making sure you understand how to set this up. We're connecting a cable, Batman is connecting a cable to the top of a pole that is 12 feet tall. So here's the pole, connecting the cable up there. The cable will be anchored to a stake 5 feet from the base. So we're walking 5 feet from the base of the pole, and we're putting that stake right there. How long is the cable? So we just want to know, what is the hypotenuse? So that question is asking, what is the hypotenuse in this missing triangle? So leg, hypotenuse. I know this video is going a little bit long, so I'm trying to keep this relatively short. So leg squared plus leg squared equals the missing hypotenuse squared. 25 plus 144 is 169 equals x squared. Take the square root. That is going to be 13. X equals 13. So the cable is 13 feet long. Pretty tough section, especially with the Pythagorean theorem tacked on to the end of that.